Welcome to another video on my Raspberry Pi 3 in combination with the PiXtend PLC, programmable logic control. Usually used in industry, but this one can be used for anything. Last time I had a severe problem with networking. How that occurred and why it occurred, I have no idea. Because this time no such thing. It just starts and works nicely. So I can quickly go on with the topic and focus of this one, which is a continuation of last time, Python versus C. You can program in both, obviously, and with Python I have tried numerous things and not everything with equal success. So last time with C I thought I had a nice idea, and then I ran into a problem with a header file, a library. Hopefully solving it this time. So let's see how that is going to develop. So with yet another review on the laptop, Tiger VNC virtual network computing, obviously, Python, C code, terminal to compile. Then here the SSH terminal, in which I run directly on the Raspberry Pi as well, but no VNC. This is obviously the camera and the schematics. So where to start? Well, first of all, I ran into a problem with compiling last time. So let's see if that is still happening. You never know. And yes, no input file. Oh yeah, of course. Because then it is a very nice if I'm actually in the directory. And this is saying it all, undefined reference 2. And that means that the PiXtend header file is not there somehow. Last time I already checked, and this and this is actually correct. So where to look for it? That's the problem. That's where I left off last time. So I have to find out. Searching the net for any other problems with the PiXtend header file, I come across a notice that, or remark, that somebody else has problems, and then I find that this might be a solution. Linking against the library, so keeping it out of the header files. Haven't tried yet, so let's just see if this works out. And then I get a lot of different things. And one of the other options included was but I'm not sure if this one is yet included on the system, so let's just try. Oh, that's a very different version. Oh, these are warnings. These are only warnings and not errors. That means that I now could have an executable. And I do have an executable now. So that was a very good idea. And yes, it works. So although there are two warnings, implicit declaration, but it does compile. So indeed, where it comes to this line, it can go. This one can go as well, keeping the code clean. Not strictly necessary, but nice to read. So I have to link to two libraries, being PiXtend and RaspberryPi. Now, if you have watched my videos on the Raspberry Pi 1 and 2, with respect to linking electronics, etc. Yes, I'm using the wiring Pi extensively, and there I usually link them with the -L or -L option. So yes, now I can go on. Now before I go on, I want to test if the program actually works. Meaning that, of course, I have now digital input, which comes back as 0. So now I have attached the breadboard and applied the 5 volts power that I used to do. I've connected this wire to digital input 0. Now let me refocus a bit. Yeah, better. And the point is now that this program is not repeating. It doesn't have a while statement. So I have to press the button and then run the program. So and when I press this button, then this LED will yes, it's visible on screen as well. So now let's go for it. And it says 0, which is not promising. So how come it is 0? Digital input is digital in, but which one? That's a good question then. Once again, something to find out. It gets a little interesting now, because in the manual it says that this function returns the value of the digital input when it's 1. If all inputs are 1, it returns the number 255, which is correct, because it starts at 0 to 7, 2 to the power 0 plus 2 to the power 1, etc., etc., until 2 to the power 7, all accumulated returns 255. That also means that if I test out each individual one, I should get 1, 2, 4, 8, 16, 32, 65, 64 and 128. So if I change this one and put it in here, the value I should get is 128, and this LED should light up. But will it? No compilation needed. Just pressing the button and run the program. Nothing. Okay. absolutely nothing is being read. So what happens if I open a new tab and run my Python program? Scroll back in time. Yes, run it. And then I'm very curious what happens with the LED, and then more specific, that LED. Turning away the light, maybe I can see it better then. But I don't see anything. And there is no sign of digital. So is there anything in here at all? That's the problem now. That's the question. Time for some measurement again. Because measuring is knowing. Oscilloscope engaged, and only one probe attached, so these 3 lines are to be ignored now. And voltage is on 5 volts, so one cell is 5 volts. Then what you notice is here a flat bottom, so it gets truncated. But another thing is, if this is 5 volts, then why is the period so incredibly large? Another thing is, the probe is on this wire, so in schematics the probe is here at this location, and yes, this is now located here, but it is really at this location. VCC voltage is 5 volts because the power supply is at 5 volts. So this is something that is without the button pressed in fact not possible unless I give, let me show you, that is way better. So I am pressing the button and you see 5 volts. Actually slightly less than 5 volts. It's 2.5 volts, which is possible because of the resistor. Wait a minute, resistor, that means that the probe is oh wait, this is not entirely accurate. I have a switch and oh, that's a nice thing, wait. So yeah, it is correct after all. So this one is not here. I have to change this. Oh yeah, this is not good. So this one goes here. Here and right here. This is the actual situation. Yes. So because there's a resistor here, the voltage drops a little bit and you have this situation. 2.5 volts. So what is the threshold of the input? What is the threshold here? That's a good question. So let's quit the Python. Let's run. Go here. Press the button again. Go. It says 0. So I most likely should change the setting schematics. Or I have to increase the voltage. How much voltage does it need to operate? I have seen the LED burn weakly, but if you want to have it burn brightly, you have to increase the voltage. So I think 2.5 volts is even too small to have it burn really. Interesting thought. So how do I accomplish that? Probably by taking away the resistor. And with these musings and results, I say thank you for watching. If you like this video, please subscribe to my channel and give the video a thumbs up. Leave a comment or suggestion, please. I thought correct. Whatever. You can also follow me on Twitter and Instagram. Please show your support by becoming a patron and have your name mentioned and become a co-producer. More information on my website and on my Patreon page shown in the video. And if you don't want that, you can also make a donation via PayPal or IBAN. Please see below the video for my website and other information, or wait for the final segment. This is going to be continued, obviously. So have a nice day, take care, bye bye.